Good afternoon, student friends. I once again welcome all of you to our online learning class of B.Sc. Second Year Analytical Chemistry. In last lecture, we have learned about the Lambert-Beer's law. In this lecture, we are going to learn about the deviation from the Beer's law. Let's begin with the deviation from Beer's law. A system is said to be obey Beer's law when a plot or a graph of concentration and absorbance gives a straight line. As you know that in the Beer's law we have seen when we plot a graph versus concentration versus absorbance, we will get the straight line passing through the origin. So when a non-linear curve is obtained, then the system is said to undergo deviation from Beer's law, because Beer's law states that the absorbance and concentration are directly proportional to each other. So they vary linearly with each other and we will get the linear graph. But in case of the deviation, when we get the non-linear curve, then the system is said to be undergo deviation from Beer's law. There are two types of deviation. One is positive deviation and another one is the negative deviation. See here what one is positive deviation, another one is the what? Negative deviation. So if the curve tilted towards the left side, then it is positive deviation. If the curve tilted towards the negative side, then it is the what? Negative. Means what? The right side, then it is the negative deviation. Means what? Deviation to the upper side of the ideal calibration curve is a positive deviation. Deviation to the lower side, a downward side of the ideal calibration curve, will get the negative deviation. Then what is the positive deviation? It results in when a small change in concentration produces a greater change in absorbance. Means what? If there is no linearity in the absorbance and concentration. Means what? The absorbance, more increase in the absorbance takes place when slightly increase in the concentration or change in the concentration. Then negative deviation, when occurs, it results in when a large change in the concentration produces smaller change in the absorbance. It is what? Reverse to that of the positive deviation. If we change the the large amount of concentration, but there is only slight deviation occurs in the absorbance, so we'll get the negative deviation. See here what the positive and negative deviation is what shown when we plot the graph absorption versus the concentration. We'll get the ideal calibration curve in case of the if this solution obeys the Beer's law, and if the solution does not obey the Beer's law, we will get the such type of the deviation, that is what? Positive deviation and the negative deviation. Then deviation from Beer's law, a system is said to obey a Beer's law when a plot of a graph of concentration and absorbance gives the straight line. Then these deviations from the Beer's law can be classified into three categories. That is real deviation. These are fundamental deviation due to the limitation of the law itself. Means if the solution itself has the limitation, that is law, the limitation given by the law is not followed, then this is what the due to what the limitation of the law, the some deviation is occur. That deviation is known as the real deviation. The second one is the chemical deviation. These are deviations observed due to the specific chemical species of the sample which is being analyzed. This is depend upon the total chemical nature of the analyte. And instrumental deviation, that is instrument deviation, these are deviation which occurs due to the how the absorbance measurements are made depending upon the instrument used. So these are the types of deviation. Beer's law describes the absorption behavior of dilute solution only, so it is a limiting law. because it is not applicable to the concentrated solution. It is only applicable to the dilute solution. This is what the one limitation. At the high concentration exceeding 0.01 molar, solute molecule can cause different charge distribution on their neighboring species in the solution. So this affects the absorbance. Since at high concentration it results a shift in the absorption wavelength of the analyte. So we will get the shifting of the wavelength of absorption at the higher concentration. Some large ions or molecules show deviation even at very low concentration. So some of the molecules or ions also shows the deviation due at the low concentration, also very low concentration. For example, methylene blue absorptivity at the wavelength 436 nanometer fails to observe BS law even at concentration as low as 0.01 molar. So because it is intense nature of this methylene blue, the high analyte concentrations alters the refractive index of the solution. It affect the absorbance obtained. So the RI is also what the altered by means of or affected by means of the high analyte concentration. Then deviation from BS law. Second type of deviation is the chemical deviation, occurs due to some chemical phenomena, that is what association, dissociation, interaction with the solvent to give a different product. If the molecules associate to form a associated product, they combine, then will get the different absorption. If the ions are get dissociated in the form of what the substances get dissociated in the form of ions, then we'll get the different types of the what dissociation. So and another one type the what if we take the solution solvent and that substance, and if there is a reaction between them, then we'll get the different product. So this is what the another one what effect that affect the absorbers, and which indirectly affect the what the deviation, or it does not follow the BS law. So example of that type of the what process is that a phenol red undergoes a resonance transformation when moving from the acidic to basic form. That is what in acidic form it is yellow and in basic form red. So absorption it changes with change in the color. So there is a change in the color, means what it is changes with the due to the change in their association or dissociation happens or reaction occurs. This phenol red undergoes the resonance transformation, then it changes the color. So due to this resonance, the electron distribution of the bond of the molecule changes with pH of the solvent in which it is dissolved. So in acidic medium it shows different color, and in basic medium it shows a different color, that is what red color. Due to this change in the color in the various medium is depending upon the resonance, that is what the electron distribution of the bond of the molecule. So it is depending upon the pH. So the acid and base forms of phenol red along with the UV spectra at different pH demonstrate chemical deviation of BS law in UV visible. So how this yellow color shows the wavelength and the red color shows the wavelength. Here what red color shows the higher wavelength and the yellow color shows the lower wavelength. So this is the one of the fact that the chemical behavior, chemical deviation. Second one is the what the instrumental deviation and its limitation. So polychromatic radiation, we use the monochromatic radiation, but here what the polychromatic radiation. Polychromatic radiation means the radiation contains more than 2 wavelengths. So a Beer law is strictly followed when a monochromatic source of radiation exists. It is what when the Beer's law is obeyed, when the monochromatic light is present. It is common to use a polychromatic source of radiation with continuous distribution of wavelengths along with monochromator is used to create a monochromatic beam from this source. So if you are using what the polychromatic light, but it is necessary to use the monochromator to get the monochromatic light. So it is the deviation occurs, instrumental deviation occurs if we not use the monochromatic light or monochromator. So stray radiation, scattered radiation is the radiation from the instrument that is outside the nominal wavelength band selected. So this is one another drawback, that is what the stray radiation. This radiation is what scattered by means of the instrument itself. So this radiation is due to the reflection. This radiation is due to the reflection. The radiation is due to the reflection and scattering by the surface of the lenses, mirrors, gratings, filters, and windows. So these are the optical instruments. So there is a reflection also occurs. Reflection of the radiation also occurs. Due to this, the deviation also occurs. The wavelength of the stray radiation is different from the wavelength band selected. So this stray light interferes in the original absorption band, that is radiation. So it has the different. So now what it is the different wavelengths than that of the radiation selected for the absorbance. Then the radiation existing from the monochromator is often contaminated with the minute quantities of scattered or stray radiation. Where we pass this radiation through the monochromator, we will get the monochromatic light, but this monochromatic light is what associated with that reflected or stray radiation also. If the analyte absorbs at the wavelength of the stray radiation, a deviation from Beer's law occurs. When the analyte or the substance does not absorb the selected radiation and it absorbs the stray light, then we will definitely get the the deviation, that is from the Beer's law. Mismatched cells. If the cells holding the analyte and the blank solution are having different path lengths or unequal optical characteristic, it leads to deviation from the Beer's law. If the reference cell and the sample cell has the same path length, then there is no deviation occur. But if we use the different cells or different optical characteristics for the sampling cells, then we'll definitely get the deviation from Beer's law. Due to improper slit width, if we use the improper slit width at the different sides or different slit, that is entrance slit and exit slit, we will get the different radiation, that is different type of radiation, and we will get the different absorption, and we will get the deviation from the Beer's law. If the width of the slit is not proper, deviation occurs due to undesirable radiation to fall on the detector. So we will not get the real radiation which falls on the detector or which is passed through the sample. So these undesirable radiation are absorbed by the impurities present in the solution of the sample. So this type of radiation, stray radiation or improper radiation, or what the another type of radiation, undesirable radiation, is absorbed by means of the impurities, and they show the different absorption than what we are expecting. So we will get the deviation from Beer's law. It leads to the change in the absorption of the sample, so we will get the deviation from the Beer's law. So this is about the deviation from the Beer's law. If you have any question, any queries regarding this topic, please put the question in YouTube comment box. I will try to answer the questions. Thank you. Thanks a lot. Have a